Hello everyone, welcome to the NN Classroom. Today, I'd like to share with you a past paper question from 2019, time zone 2 in May. So question number 15, talking about relating to the topics of topic 6, kinetics, especially the understanding of an energy profile. So that is this kind of diagram. Let's see. What is the activation energy? Really important term in topic 6 of the keyword reverse reaction. That means we are not asking you to locate the activation energy of the direct forward, but the backward. The reverse means the backward reaction. That means if the reaction is capable to go backwards, what will be the activation energy? For sure, we should notice that the reaction progress, or simply called the reaction coordinate, sometimes some books will say in this way, that we should notice that it is just work like a timeline, that the reactant is on the left side and the product is on the right side. So that's why the forward reaction goes in this direction, from our left all the way to the right. But now, are they asking for me to go forward? No, asking me to go backward. So that means now my direction should point from the product, now go back to the reactant, like this, right? Just like walking up to the mountain and then go back down to the reactant. So that is the reverse reaction, the backward, right? So again, based on the definition, what is the activation energy? That is the minimum amount of energy required to trigger a reaction to occur. So that's why, that is the minimum payment. That will be the energy gap between the starting position to our peak. So this is the peak across the entire energy profile. No matter forward or backward, still this is the peak. The peak is what we call, also known as the transition state, or so-called the activated complex, right? In a more biological sense. So that is the most unstable state. That means whenever we can go to this transition state, supposedly we can go to the product side so easily, right? So that's why the energy gap between our starting point to the peak most position, so that is transition state, that gap will then be the activation energy. So that's why if we are going forward, for example, if we go forward from the starting point, reactant, to the transition state, this energy gap, so that is the magnitude in B, is the activation energy for forward. So that's why for B, remember, is the activation energy, symbol EA, is the activation energy of forward reaction. But that is not our choice, because we are now wanting to figure out backward. So that means the starting point now goes to the product side and all the way goes to the peak. So the gap in between, C. So that will be the activation energy for the reverse reaction. So answer C.